Hello, I'm here to explain the fourth experiment of Unix lab. It's base conversion using shell scripting. The first question is to convert decimal to binary. So let's look at the code. So here I tell print decimal to binary and I tell the user to enter decimal number, and the decimal number is stored. While decimal number is not equal to 0, I do the following operation. That is, I find the remainder of the decimal number by calculating the decimal number mod 2, and then I divide the decimal number by 2. After doing this, the binary number is stored in A, that's the remainder, and it is printed in reverse order. So let's see how the code runs. So here I enter the decimal number as 8. So the binary is for it to 1000. So next question is to convert binary to decimal. So for that, the code is here. Here I print binary to decimal and I tell the user to enter a binary number. I read the binary number as bi and I initialize I as 0 and decimal as 0. So while the binary number is not equal to 0, I do the following operation. That is, I find the remainder of the binary number by finding mod 10, and then the decimal number is added with 2 power the I value, which is incremented, multiplied with the remainder. The I value is incremented by 1 in every loop. Then the remainder is binary number is then divided by 10. After doing this, we get the decimal number. So let's execute and see. So here I enter the binary number as 111, and so the decimal for that should be 7. The next question is to convert octal to hexa. So for that, the code is as follows. So for first, to convert octal to hexa, first you have to convert octal to decimal and then decimal to hexa. So for that, I enter the octal number and I again initialize I as 0 and decimal as 0. While octal number is not equal to 0, I do the following operation. That is, I find the remainder octal number by doing mod 10, and the decimal number is added with 8 power the I value, which is incremented by 1, multiplied by the remainder A. Then the octal number is divided by 10. So then while decimal number is not equal to 0, I do the following operation. That is, I find the remainder decimal number by doing mod 16, as 16 is the power of base of hexa, and if it is less than 9, I print the hexa decimal number as itself. If it is equal to 10, I print it as A. If it is equal to 11, I print it as B. If it is equal to 12, I print it as C, and 13 as D, and 14 as E. Else it will print it as F. Then the decimal number is divided by 16, and hence we get the hexadecimal number printed in reverse order. So let's just execute and see this. So here I gave the octal number as 12. So I get the hexa as A, because octal, when we convert it into decimal, we get it at 10, and the hexa for 10 is A. So the next question is to convert hexa to octal. So for that, the code is as follows. Here similarly, like octal to hexa, I take the hexadecimal number from the user and I print decimal as 0, j as 0, and I do the following operation. That is, I if the multiply the number with the I value, which is incremented, and then it is added with the decimal number. Similarly, it is done for each of the values, and then after doing all this, I printed it as 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F respectively. After that, I do I as I decrement I as 1 and increment J as by 1, and then I print the octal number in reverse order. Let's just see how this code is executed. So here I enter the hexa number as F. So for hexa number as F, the corresponding binary is 15, and for that the octal number is 17. So hexadecimal number is converted to octal number. The last question is to convert decimal to hexa. So for that the code is as follows. Here I enter the decimal number from the user, and while the decimal number is not equal to 0, I find the remainder of decimal number by doing percentage 16, because the base of hexa is 16. If that number is less than 9, I print the hexadecimal, and if it is equal to 10, I print A. If it is equal to 11, I print as B. Similarly, 12 as C, 13 as D, and 14 I print as E. Otherwise, it will be F. So then the decimal number is divided by 16, and then the hexadecimal number is displayed in reverse order. So let's just execute and see this. So here I enter the decimal number as 15. So the corresponding hexa for that is F. So here is how the experiment ends. Thank you.